Welcome to part 2 of the Solving Rational Inequalities video. This video has 2 more examples, a bit more complicated in the expressions that are used, but the process is still the same. We'll begin with the inequality 2 divided by x minus 1 is greater than 3 divided by x plus 4. We'll begin by solving this as an equation, substituting the equal sign for the greater than sign. Because I have a single fraction on either side of the equal sign, this is a proportion, which I can solve through cross multiplication. So I have 2 times x plus 4 equals 3 times x minus 1, or 2x plus 8 equals 3x minus 3. Solving for x, I'll find that x equals 11. Notice the inequality symbol has no equal sign, which lets us know I'll use an open circle and parentheses whenever the number 11 is involved. I also need to consider my domain restrictions. I cannot have x minus 1 equal 0, nor can I have x plus 4 equal 0. So this says to me that x cannot equal 1, nor can x equal negative 4. Again, these are open, and I will be using parentheses on the number line to represent these values. So I have negative 4, and I also have 1, and I also have 11, all with open circles. Now I'm ready to test points. I'll use negative 5 for the interval of values below 4, which will lead me to a statement that says 2 divided by negative 6 is greater than 3 divided by negative 1, which is a true statement since negative 1/3 is greater than negative 3. So I will have shading for the interval of values below negative 4. Next, I'll use a test point for a value between negative 4 and 1. 0 is an easy one to use, which will lead me to a statement of 2 divided by negative 1 is greater than 3 divided by 4. Well, no negative number is greater than any positive number, so the interval between negative 4 and 1 contains no solutions. Next, I have the interval between 1 and 11. I'll use 2 as my test point. So I have a statement that says 2 over 1 is greater than 3 over 5, which is true since 2 is greater than 3/5. So I have the area between 1 and 11 shaded for solutions. Lastly, I'll test a value greater than 11. I'll use 12. This leads me to a statement that says 2 over 11 is greater than 3 over 15. And 2 over 11 is just slightly smaller than 3 over 15. So this is not a solution, so we'll have no shading above 11. And so in writing my solution, values less than negative 4, so from negative infinity to negative 4 are part of the solution. I'll combine that with values that are between 1 and 11. Clean up this left parentheses a little bit and make that clear. And so this is our solution. To graph this on your calculator, you can go into y equals. It'll be 2 over x minus 1 minus 3 over x plus 4. And you're looking for values where y is greater than 0. It'll be a really interesting graph for you to view. For our last example, we have x minus 2 divided by 2 times quantity x minus 3 is greater than or equal to x divided by the quantity x plus 3. And we're looking for all solutions of x where this inequality is true. So let's solve it as if it were an equation. And we have x minus 2 over 2 times x minus 3 equals x over x plus 3. Again, we have single fractions on either side of the equal sign, so we can treat this as if it were a proportion and just cross multiply. So we have x minus 2 times x plus 3 equals 2x times x minus 3. Distributing, we end up with x squared plus x minus 6 equals 2x squared minus 6x. To begin to solve this, we need to get all of our terms on one side since we have a quadratic term. And in doing so, we obtain x squared minus 7x plus 6 equals 0. This factors very nicely into x minus 1 times x minus 6 equals 0. Zero product property, we're not sure which factor equals 0, but one or both of them must in order for the product to equal 0. So we set x minus 1 equal to 0. Also x minus 6 equal to 0, so x could be 1 or x could be 6. As far as our domain restrictions, I cannot have x minus 3 to equal 0, nor can I have x plus 3 to equal 0. So along with the critical points of 1 and 6, we must recognize asymptotes at 3 and negative 3 as we set up our number line. Now, for 1 and 6, because we have a greater than or equal to, these will contain open circles or open intervals. However, for the asymptotes, said that incorrectly, I'm sorry. Let's go back and change that. For x equal 1 or x equals 6, because it's greater than or equal to, these should actually be closed intervals, which means we're going to use brackets. And for the asymptotes, we would use open or parentheses. Apologize for that mistake. Alright, so here's our number line, and we need to include the numbers negative 3, 1, 3, and 6. And we need test points in each section. I'm going to go with negative 4 first. This gives us a statement of negative 6 over negative 24 is greater than or equal to negative 4 over negative 1. And 1/4 is not bigger than 4, and so I will have no shading in the area below 3. Next, I'll choose 0 for the intervals of values between negative 3 and 1. This will lead to a statement that says negative 2 over negative 6 is greater than 0. And 1/3 is greater than 0, so I would definitely have shading between 1 and 3. Excuse me, negative 3 and 1. Then for between 1 and 3, I'll choose 2. This will be a statement of 0 over negative 2 is greater than or equal to 2/5, which is not true. 2/5 is actually greater than 0. For the next section, between 3 and 6, I'll choose 4. This will give me a statement that 2 over 2 is greater than or equal to 4 over 7, and 1 is greater than 4/7, so I will have shading between 3 and 6. And my last section, I'll choose 7. I will have a statement that says 5 over 8 is greater than or equal to 7 over 10. 5/8 is just a little bit more than 0.5, which is not greater than 0.7, so there are no solutions in that area. Now going back to open or closed, I should have closed on 1, closed on 6, open on 3, open on negative 3. So as I write my interval for the solution, my solution is open on negative 3 to 1, closed, union, open on 3 to 6, closed. This is our final solution, and I hope this has been helpful. This is the last lesson for our unit, so make sure that you ask any questions that you have on Edmodo as you continue to prepare throughout the week. I pray you guys stay safe and warm. See you soon.